Okay, so today I'm going to talk to you about the coursework that you need to do for this unit. All right, so I've uploaded it, the document on Moodle. Everything that you need to know is there, but you just need lots more explaining from my side so that you understand exactly what it is that you need to do. So first things first, deadline for the coursework is 3:30 in the afternoon on the 21st of January. Okay, so it's pretty far away. However, you will need to start working on it almost straight away, right? Because it is quite a bit of work. So you will submit this via Moodle. Okay, so there will be a submission inbox in the unit's Moodle page where you can go and submit it. I would prefer the report to be in either Word or PDF format. I would really prefer Word, actually, to be honest, because I can easily see the word count on it as well. All right. It can be Word or it can be ODT as well if you're using OpenOffice. So it's a coursework on an individual basis, so each of you must do it on their own. Okay. So what do we have? So first of all, the assignment has been written so that there's not one single correct answer. There are only correct methodologies. All right. It's important that you develop your investigative ability during the assignment. You must attend all taught sessions so that you receive constant feedback on your ideas so that you can improve them. Failure to attend sessions may affect your ability to effectively explore the problem space and the ease with which you use OPNet. So what's going to happen is I have a couple more lab sheets with regards to the unit. They are all directly related to what you have to do for the coursework. And then what I will do is I will be essentially running drop-in sessions. So I think it's going to work out to as one drop-in session before Christmas and 3 drop-in sessions after the break, after the holidays, in which you can come and ask me questions about the coursework. And of course, there will be 4 essentially tasks for you to do in the coursework. I will go through those 4 tasks during those drop-in sessions in much more detail. All right. So what do you need to do? You must identify a gaming application, take a model of the traffic, and then build a network, adding background traffic until you expect the perceived quality of service to be poor. You should then investigate the effect of adding some form of quality of service to the network and attempt to mitigate the effects of background traffic on the gaming application. So it is a coursework that's based on OPNet, of course. All right. So you need to do it on OPNet. And it is based on you generating some traffic, capturing it, importing the traffic into OPNet, creating a simulation for it, creating a network for it, and then trying to optimize that network. The whole idea of the unit is essentially network optimization, and we're going to try to do that by implementing some quality of service scheme. Now, I'll get back to the tasks later. I will quickly explain the rest of the of what's in here. So expected deliverables from each individual is a report of 3,000 words. Okay, it shouldn't be less than 2,000 words. It shouldn't be more than 3,000 words. The contents of the report must be this specifically. All right. So you need to have a title page, the content page, some introduction, a short introduction reviewing the project, some literature review, which will be a 500-word maximum literature review. I have a 500-word maximum limit on this because you can start talking about QoS and all the different schemes and everything that exist, and you can just write thousands and thousands of pages even just on this thing. Okay, so because I don't want you to fill the coursework with useless info. All right, the literature review must pertain exactly to the methods of QoS that you've used in your project specifically. All right, so any theory we need to know in order for us to understand how you're actually working or what you're actually doing on your project. Methodology, so details of your methodology, although that will be pretty easy because really the methodology is the 4 tasks at hand. Simulation configuration. So you must give details of any important design decisions, because this will be a network design that you will have to come up with. All right. How you will collect data, so how how you choose the game to play, how you will import all the traffic into OpenNet and everything else. Findings. You need to list your findings and results for each stage of the network development. So that would mean network design and basically getting the simulation to run. So one of your first findings would be the actual simulation not coming up with any errors and producing meaningful results, showing that traffic is going around. Another stage would be of you basically adding the background traffic and seeing what effect that has on the actual network traffic. And then the third stage would be the most important one, would be the implementation of QoS and how it actually improves your network back to what it was. All right. Then in the conclusion, and you need to have an appendix as well. There are some important details with regards to the report. You need to use font 11 or 12. Paragraph alignment must be justified. Font must be Arial times New Roman or Calibri. Must use single line spacing and everything else. Tasks 1 through 4 will award 80% of the coursework mark, and presentation will award 20%. This means what? This means that doing the 4 tasks here will give you 80% of the coursework, or is responsible for 80% of the coursework mark. However, making sure that you adhere to all of this, okay, so making sure simply that you have a title page, a contents page, you have introduction, so you have the correct format on the report, and you have the correct font size, paragraph alignment, and everything else, will straight up give you 20% of the coursework. All right. As far as I'm concerned, these are 3 marks. Okay, because it's very easy. All you have to do is just make sure that your report's format adheres to this. Okay.
Quick question. Sorry to be a pain. It says paragraph alignment must be justified. So what do you mean by this? We're supposed to make some sort of fancy paragraphs? Or?
So no. So justified paragraph alignment is when both the sides of the paragraph are straight with the edges. So if I scroll up, so this is justified. Okay.
All right, cool. I've never had to hand in anything that looks so professional, so I'm scared.
Honestly, it's just 3 marks, really. Okay. So, document presentation and everything, there's some indicative reading in the end and everything, and the general marking scheme for this, and that's it. Okay. So the thing that you must be careful about, first of all, is just to make sure that the coursework looks like this. So now let's talk about the contents. All right. 4 tasks. Measure traffic, find the traffic model for each of the applications. So the coursework is asking that you play a game and capture the traffic for it. We'll see in the next lab sheet last week how you can actually capture traffic and what you can do to import it into OpenNet. So we've seen so far how you can create traffic in OpenNet using the pre-built application definitions inside it. All right. So I will show you next week how to actually import traffic into OpenNet, or how to make traffic in OpenNet look as similar as possible to the actual traffic that you captured. So the first thing that you need to do is you need to play a game. All right. This can be any computer game. It can even be a game on the PlayStation if you like, as long as you have the ability to capture the traffic that this game is generating. All right. It has to be an internet networked game, and it must not be web-based. So the protocol of communication for the game must not be HTTP. All right. So it should not be a game that is played inside the browser. It can be any of the shoot 'em up games. It can be World of Warcraft. It can be whatever you like. All right. I don't mind. I don't care. You know, this is going to be your decision to make. So the first thing that you need to decide is which game to play. If you don't play games, I find it hard to believe, but there are people, yes, that's fine. You can choose one and play it. I would recommend that you play Quake Online. All right, it's very easy to set up. It's free because it's old. It exists both in Windows and Linux, and you can play it, and it fulfills, for me, the most important criterion. It gives you lots of information about the game infrastructure. So the reason to choose a game would be first because you know how to play it, or you already have it installed and you know it and you're used to it. However, the second most important criterion for you to choose would be to actually be able to find information about the game. So you need to be able to filter the traffic. So you need to know how to distinguish the captured traffic from your computer and how to tell apart which traffic is game traffic, which traffic is network management traffic, which traffic is something else that's happening on the network, and so on. All right. The best and most efficient way to do this is to know the IP address of the server that you're connecting to. All right. So, or you can know the port on which, or the port or the ports in which the traffic of the game actually works. Although usually they are UDP and they're connectionless, so it varies really between games. So, two criteria. One is that you know how to use the game. Two is so that you know how to find lots of information about the game. So it has to be a game that gives you easily, readily available information about its server, infrastructure, ports that are being used, type of traffic that's being used, and so on and so forth. All right. Of course, it doesn't mean that you have to play the game and win. All you need to do is start up the game and generate some traffic. Of course, you generate some traffic by playing. All right. So you have a game, you just run around in the game space, create some traffic. To capture the traffic for this, you can use Wireshark. You can use any traffic analyzer software you like. Of course, it doesn't matter. All right, I'm not particularly fast about it. However, I would propose that you use Wireshark. When I do, I think it's the next lab sheet, I will show you how to actually use Wireshark to capture traffic and how to filter traffic on your computer at home. Okay, Wireshark is free. It runs in Windows and Linux, I think on the OS X as well. So you can use that, and I would recommend it. But if you're used to some other traffic capturing software, then that's fine by me as well. All right. So task number one, measure traffic, find the traffic model for each of the applications. Find the traffic model for each of the applications means you need to find the characteristics of the traffic that you can import into OpNet. Those usually are three different items. The first one is packet size. So how big are the packets that are being generated by the network? The second one is packet interarrival time. So how often do those packets go in and out of your computer? And the third one is traffic shape. What is the statistical model by which the traffic is being sent out? So does it have like, is it like a constant traffic with a constant bit rate? Is it exponential? So does it go up in spikes? Is it normal? It's like a normal statistical curve. What is it? So these are the three different details that you will need to figure out about your traffic. The two of them are pretty straightforward from Wireshark, for example. It just tells them to you. And the third one, you can work it out quite easily as well if you put all the data in a graph. All right. So this is the information that you need to get out of your first stage, which is essentially just running the game, playing it, and capturing the traffic using whatever software you want to use. The second task is to build a test network, decide upon the number of nodes, number of users, background traffic, and the network cabling infrastructure. I can give you some general guidelines as to what exactly I want on this. I want a network that is big enough So I want a network that is at least nationwide. Okay. I want it to have 5 different cities, and each of them, I want them to have at least 10 gamers inside it. This means what? This means that I want a total of minimum 50 players being connected at the same time on the server playing the game. So I want 50 simultaneous traffic generators, traffic users in the network that are playing the game, that are playing the application that we're interested about. All right. And I want the network to be big enough. So the network, I will show you in detail what I expect the network to look like. All right. So we want it to be like the workstations of the people playing the game, connected to a switch, connected to a router that will be the main backbone router that connects all the other routers together. So essentially connects all the cities together and then to a server somewhere. You can make this as realistic as possible. It's down to you. The network design itself is completely up to you. All I want is 50 people playing the game, so 50 workstations playing the game on a nationwide scale at the very least. Okay, in the past I've had people making it on a European scale or the worldwide scale, it doesn't matter. Generally, if you're playing a game online, the server that you're connecting to will be a relatively local server. So it will be in your country or it will be in a country nearby. So, it's highly unlikely that you'll be playing a game in the UK and the server will be based in Australia, because that would just create ridiculous lag for no reason. Okay, so that's what I need from the test network. I will give you some examples of test network ideas later on as the time progresses, and you can basically build your network so that you have the traffic in there. Once you do that, the most important item for this is item number 3. After building the test network, add the traffic from the new application. Okay, so you will create your network. You need to figure out the way to create the traffic as accurate as possible that you have captured from your computers. All right, so you need to create an application in the game that is as close as possible to the gaming application that you've captured, to the traffic that you've captured with Wireshark. This will create a simulation that you will run. You will get results for, let's say, packet end-to-end delay for your current application. All right. And that will be what we call the baseline. So that will be what we will compare all of the further traffic that you will create once you modify your project. So step number 3 is very important because that will be the baseline scenario of just the game running in the network and seeing exactly how much traffic, how many bits per second of traffic it creates in your network. So you will know how your network actually behaves in an optimum environment without any other interference, any other background traffic inside it. All right. And then finally, we move on to step number 4. You need to create 2 more scenarios. It's very easy. You just duplicate your base scenario. And you need to add some background traffic into the network and break it. So you need to figure out how much traffic you need to add in order to make the application delay unacceptable. So first of all, you need to decide what unacceptable delay means for your game. There are games that are quite resilient to delay, but there are games that are very sensitive to delay as well. All right. So for example, if you don't want to have any lag streaming a video online, you need to have a maximum of 150 milliseconds of end-to-end delay for your packets. All right. Your games will be at worst something like that. In all probability, they will require half or a third of that delay so that you can actually play smoothly on them and not having any lag. All right. So you need to import background traffic and decide, or maybe you can find online information about the game. People saying, once you get up to 60 milliseconds of delay for Far Cry, you can't really play it anymore. All right. So you can find this, or you can figure it out by yourselves. So you create the second scenario that has the background traffic in it and make the application delay go higher than what it is acceptable for you. Solve that. You can then create the third scenario, which will introduce some quality of service scheme and will bring back down the application delay back to desired levels. So essentially it will prioritize the gaming traffic over all of the other traffic that exists in your network that we'll just call background traffic, whatever it is, right? And try to get the application to behave at acceptable performance, even with background traffic in the network. Okay, so this is what the project is about. You decide on a game, you play it, you capture the traffic, you figure out the characteristics that you need from it, packet size, packet arrival time, statistical distribution. You create a network according to the specification that I said in Operate, 50 gamers, at least worldwide, nationwide, 5 different cities minimum, so that they have some distance between them. You create the baseline scenario in that simulation with the players playing the game and only the gaming application existing in there. Then you duplicate it, you create a scenario where you have background traffic and you break the application. So you create delay that is unacceptable levels. And then you create a third scenario or more, depending on how many quality of service schemes you want to try out. And you implement QoS and you figure out which QoS scheme, it might be more than one, actually brings back your traffic down to the levels of the original baseline scenario and makes the game acceptable to play. Okay. So this is the basic intro to it for today. So, any questions?
Ves,
Yes.
do you, last time we spoke about having OpNet, we also mentioned that if they could do it, that we would have local.
I'm still trying. So I've started the call with IS. They said the problem is, like Cedric and Alex, our own system administrators, say that there's nothing that they can do to the server itself, and it's not an application thing, so it's a network thing. So the licensing servers available ports for the license need to be allowed through the university's firewall so that they be accessible on the range of IP addresses that are being used by the VPN connections when you're connecting onto the university. So it's the networks team that needs to do this. So this means that I actually need to, I've started a call for this, and I'm expecting it to progress within a couple of weeks. I'm hoping it will be done before we go away for Christmas, because I would prefer it if you were just simply working on your own computer rather than working remotely at the university. However, of course, you can start working on the university computers. So, I mean, we still have a couple of lab seats anyway to do. Okay. And by the time that you actually reach the point in your coursework that you actually need to start working on the simulation for the coursework, I'm hoping that I will have that sorted out. So that should really be like the last week of the semester, so the 6th of December or whatever it is.
Awesome, thank you.
Yeah. Anybody else? Any other questions? Okay, so I'm gonna stop the recording for this, and I will upload this on Moodle.